Alright, ladies and gentlemen, in this video we are going to identify some properties of natural logs, learn to simplify and evaluate some logarithms. But we're also going to be using some of these properties and characteristics to identify some key features of the graphs as well too. So let's first and foremost dive on into some of these properties. Now, the ones on the left-hand side, these are not new to us, folks. These are things that we have talked about already. But what the change is on the right-hand side, now we take into account what happens for the natural logs. So remember, the natural log of 1 equals 0, right? It only makes sense because it's a natural log of base e. Well, that means the natural log of e, like log of e to the e, right, is going to end up being 1. And then the natural log of e to the x, that's just going to equal whatever exponent is in there. It's going to equal x in this case, because remember, this is log base e of e to the x. Log base e of e to the x. That's exactly what this represents on over here. E to the ln of x equals x as well. That's like saying e to the log of base e of x. E to the log of base e of x equals x. So the same properties are holding true. It's just specific now to the natural log or the natural base of e. All right. So now down below, now obviously you guys might not have a partner next to you, all right? But use the above properties to simplify. I don't know why this keeps changing. Simplify to simply simplify the following problems here. So let's take a look. So I challenge you, pause the video before we dive on into these and see what you can come on up with to simplify some of these results. All right, so hopefully y'all come on up with some similar things. The natural log of 1 over e, well, we all agree this is the same thing as saying the natural log of e to the negative first power. Well, according to our properties, log base e to some power will equal said power. All right, inverse property in play. What about part B? E to the ln of 5. Remember what this means, right? This is like saying e to the log base e of 5. That's just like our inverse property happening in both our cases in this property 4 that you see on up there. So this will equal 5. You still with me? All right. What about the natural log of 1 over 3? Well, right off the bat, guys, this has to be one of those things where when you see the natural log of 1 and the natural log of e, things have to come to mind immediately. The natural log of 1 is 0, guys. So this is like saying 0 over 3. This value is 0. And then 2 times the natural log of e. Again, this is one of the ones that has to come quick to those minds. The natural log of e equals 1. And so this is like saying 2 times 1 or 2 in this example. All right. Let's continue to move forward a little bit here, guys, as we look into some more characteristics of our logarithmic functions. Now, over the next couple examples, what I want to start diving on into is the domains of these functions. So when we have these natural logs and these logarithmic functions specifically, right, when things are happening in or outside of the graphs, we're having shifts, right? Or something is happening to either the x values or the y values, right? So when we have the natural log of x minus 2, that is a shift of the natural log function 2 to the right. So a quick sketch of this graph here, guys, shows a shift 2 to the right. So really, we end up giving ourselves an asymptote in this example at x equals 2. So specifically, the domain goes from what to what? Well, if we don't go anywhere less than 2, the domain in this example goes from 2 on to infinity. Making a little sense now, huh? What about for part B? Again, let's make a quick little sketch for part B here. 2 minus x. Well, I am negating, all right, my x value this time. Or basically, I've done the complete opposite of the one above. Well, that complete opposite should show what? Hopefully you realize that's a reflection over the same asymptote. And so now we have that reflection going on over the asymptote. So how does the domain change now? Well, now we can't go anywhere more positive than x equals 2. And so in an example like this, we have our domain going from negative infinity to positive 2. All right. What about something a little bit different, though? All right. The natural log of x squared. All right. Well, again, this is only true, all right, if x squared is greater than 0. Well, good news if x squared is should always give us something value more than 0, right? And so the only problem that we have is when x is what? Well, the only issue that we have is when x is 0 itself, right? And so our graph here almost gives us a double asymptote, well, same asymptote with multiple sides according on to it. And so in an example like here, we're looking at all real numbers for x except, so x is in the set of all real numbers such that x does not equal 0, because that is the only issue that we are dealing with, because we can't have that natural log of 0 come on in to play. All right, so what I want you guys to do now on your own is take a look into some of the specific ones that we have on here, okay? A, B, and C. Now, give these three a shot on your own. I want you to identify what the domain, the x-intercepts, the vertical asymptotes for each of these three specific ones are. Give them a shot, and we're on to the next one.